spend the first half of the time. We have 2 hours lecture today. We're going to spend first half of the time to finish up the absolute value, equations, inequality. So finish up to basic 7. And the second half, I will take your questions and review for you if you have any issues on the for the midterm exam. You have questions about the past quizzes and so on and so forth. And of course, you can ask me those questions anytime. Okay, if you have one, you can ask me now. Do you guys have any questions regarding, for your review of materials in the past and everything up to now? No, not yet. Not yet. Okay, if that's the case, and I'm going to continue. So I'm going to assume that you guys are reviewing for the midterm well and smoothly, and so far so good. And so what we've done yesterday is we have covered basic 4, 5, 6, right? So these 3 types are classified into these 3 types. And also that the expression that we written here, this statement here, sometimes this statement is written down like this by itself, without attachment, without saying for what x. So when you see this statement, right? When you see this statement, how would you read it? Right? How would you read that statement? In a lot of cases, such a thing will show up. What does that mean? Right? We used this quite a lot yesterday, right? We find it very, very useful. Okay. And what's important is to realize if that is true, its opposite will never be true, right? If that is true, that its opposite is never going to be true. So this is very, very important inequality here. This is very, very important inequality here. So the way we read it is that it's this: the absolute value of any number is at least 0. Okay. Or you can say greater than 0 or equal to 0, but you should never say it's positive. You guys got it? So when you say these things, you have to be very careful, because once you say the absolute value of any number is positive, you have excluded 0. You have excluded 0. So this will make the statement false. You guys get it? So you need to be very careful as selecting words and making statements. Okay, so this statement is false and this statement is true. And also yesterday we talked about the 3 types, right? Equal, less, greater. Equal, less, greater. These are the questions, and it's in the we understand this. These are if statements. These are if statements. So to understand these further, right? We said the absolute value of any number, right? The absolute value of any number. What if the any number turn into anything? Okay, any number is turned into anything. The absolute value of anything. What I mean anything, I mean anything. You follow me? It could be a more complicated expression, such as the ones you see at basic 7. You guys look at basic 7 in the notes. basic 7a. Okay, so that's what we meant, anything. So this is turning into anything less than 3. And these will turn into anything larger than 3. 3 is just an example, okay? 3 is just an example. It could be 4, it could be -5, could be all kinds of things, and then you have to make you have to see the nature of the question, right? So in the case that if it's negative, we have discussed that. In the case the number is negative, we have discussed that. We just use this property and then to illustrate whether there's even number solution or there's no solution, right? So if this become positive and negative become any number, then we will know how to deal with that, okay? In the case the numbers we have chosen is positive, and these are the typical 3 types. These are the typical 3 types. Do you guys have any questions? So in terms of showing work, it's just that these 3, the 3 cases, right? If you understand, provided you understand the picture, you understand the meaning in the function perspective, when you show your work, and this is really how much you need to show. And in the case like that, right, when this turns into anything, right, it would just x turn into omega or anything. And of course, sometimes it requires more steps. Okay? So I'm going to show you some examples from basic 7. Basic 7a. Okay, for basic 7, I have prepared a question for you, 7a and 7b. Okay, 7a and 7b. 7a, take an example, right? If I take the first example, right, the absolute value of 5 times x, 5 times x is less than 20. Less than 20. Okay. This 5x can be viewed as omega. So it's in the second kind. It's a second kind, right? The absolute value of a number is less than 3. Now it's less than 20. So the way you set up, it would just be the next step is going to be -20 less than omega and less than +20. In this case, of course, and is implied, right? Omega is larger than -20 and smaller than 20. Like it's a picture like that, right? The only difference is this is going to be -20, this is going to be +20. Okay, -20, +20. You just have to change the numbers. And of course, omega is 5x. Okay, and then x is not completely isolated, right? X is not completely isolated, so we can take one more step and divide every side by 4. By 5, sorry, divide by 5. Divide by 5. And after we divide by 5, we get -4 less than x less than +4. And then you're finished. You're done. Do you have to show this step? This step actually is optional. This step is optional. Okay, so just two steps you finished. Okay. All right, let's look at another example. Number 4. Okay, number 4. Oh, I want to show you that there's another way to do number 1. Okay, there's another way to do number 1. Okay, or another way to do it, right? You have 5x here. You could have done this way. Okay, the absolute value of a product is a product of absolute values. So if we have two quantities, A times B, right? You take absolute value of a product, and that's going to be the same as the next. So when you take absolute value of a product, and you can, it's the same as you take absolute value separately, and then multiplication. Right? So in this case, the product of the absolute value of 5 times x will be equals to the absolute value of 5 times the absolute value of x, which is less than 20. Okay, and the absolute value of 5 is 5, right? And then we have 5 times absolute value of x, and that is less than 20. Okay, and then we divide both sides by 5. We get an absolute value of x less than 4. So in the end, we still end up here. So this review of these properties, I think we mentioned this before. Okay, there's another property, which is the absolute value of a quotient, provided we don't have a denominator, is equals to the quotient of absolute value. And this is about the only two properties on absolute value. The first one can be applied to power situation. Okay, so the power situation is also, something you can apply the product property of absolute value. So when you take a to the power of n, right, is going to be the same if you take absolute value of a and then take the power. That makes no difference. But this property is really the extension of the first one. Okay, so this is the consequence of the first one. So we're going to put these two together. Okay, and also we should review some other properties, just in case you guys may not have remembered or understand, right? Is that a situation that over here, okay, when we take absolute value of a sum, right? And this is wrong. Okay, so these are false. These are the false statement. These are the true statement. Okay. And subtraction is false. If you're subtracting and this subtracting, that's false. All right. So these are also very common mistakes. These are also very common mistakes. Okay, so these are these are also common mistakes. So you must avoid this. Okay, you must avoid this. So these are false. These are false.
Professor?
Yes?
This is Fields. I guess today the unmute is not working. You can unmute everybody since you are recording if you want.
Oh, okay. So I'm muting everyone now. Let's see. Yeah, everybody is muted. Thank you, Farouz. Okay.
You're welcome.
So these properties, you know, this is false. These are true, false, just to review. Okay. Number 4. Okay, number 4. We have a half of absolute value of a number. We don't know what it is, at least 1. What you can do is you can multiply 2 on both sides. So if we multiply by 2 on both sides, we'll get an absolute value greater than or equals to 2. All right. And this, of course, is fitting for greater than or equal to, right? Greater than or equal to. So these 3 types we have here, 2 of them is fitting for that case. 2 of them is fitting for that case. We can also do it from the function perspective, right? You can also do it from a function perspective, but here I provide that everybody knows the graph, right? Knows the graph, and its implication we went over quite a bit yesterday. But if you have any questions, please don't hesitate, okay? So the answer will be x less than or equals to -2, or x is greater than equals to 2. And then you're done. Then you're finished. Okay. Common mistake. Common mistake. Very common. Okay, I would even say it's very popular. Very popular mistake. Okay. The popular mistake is that some student, when they look at this answer, right? Some student, they can get to this place and they understand they drew the pictures in their work, and they get to this point and they feel they're not finished, okay? And they will put these 2 together and they will write it this way. They will write it that they say, okay, x is larger than 2, that larger than or equal to 2, right? So they take this part. Okay, they take this part. And then they see that x is less than or equal to -2, right? So they put it this way. This is one of those common mistakes, provided the student have gone through these steps and they presented this one as the answer. Okay, can this statement be written as this statement? No. And I already told you that's a very common mistake. The answer is absolutely not. The question is why, what it means, right? We were talking about the grammar of mathematics, right? In our earlier case, right, when we write the answer like this, the and is implied. What do we mean by that? Right? And is implied. So in order to illustrate this, I'm going to go back to the picture that we studied. In this case, Because you see that in the case of absolute value of x less than 3, we know the solution is going to be between -3 to +3, exclusive, right? So what are the characteristics of these numbers in between -3 and +3? Every single one of them is larger than -3, and at the same time, they're less than +3. So in this case, the word and is implied. The word and is implied. Basically, it says the solution is all real numbers that is greater than -3 and smaller than 3. Only in this case, only in the AND case, we can combine the inequality. Okay, so this inequality, okay, so let me put it here. This inequality, okay, implied the following two inequalities. One is x greater than -3, and the other one is x is less than 3, and they're connected by and. So this is the shorthand notation of that. Okay, so this inequality and the next inequality and the earlier inequality, this one implied the next one. And because these are axes, they're two axes, right? So we write it in shorthand like this. This also tells us only in the AND case, only in the AND case can we write it this way. Okay, only in the AND case can we write it this way. Do you guys follow me? It's a shorthand notation. It's a shorthand notation. Now, take this to the top. Okay, where we were, right? When we write negative x is between -4 to +4, -4, +4, it implies that x is larger than -4 and smaller than 4. So these two must happen at the same time. Graphically, we imply that this is the, if I take that picture, right, I'm going to bring that picture to you. I'm doing this up and down so then you relate to them. So this picture, if I bring them here, I bring it here. The only difference is that I just have to make some adjustment. I just have to make some adjustment. Let's see if that would do it, right? There's no substantial changes meaning-wise. The only difference is the number. So what it means that this shorthand notation means that all the numbers, okay, so this is the meaning. Okay, meaning all the numbers that is greater than -4 and smaller than +4. You guys follow me? Yesterday, I mentioned that my parting word for you is that you always try to understand the meaning before you put down those symbols. Or you put it down, you need to understand it. Does that meaning, is that meaning in mathematics is fitting for what you intended? Okay, because this is a new language for most of us. Mathematics is new language for most of us. This language is a subset of English language. Okay, we remove the past tenses, remove the future tenses, remove the could have been, should have been, remove those part of the grammar. You only leave us with the present tense, right? Now, with that said and done, let's see what have we done if we turn this into an inequality like that. In the AND case, when you express it like that, you need to make sure the inequality signs are facing the same direction. Some people may be confused about this sign, right? It opens to that direction, opens to the other direction. For example, what's the difference between greater than or less than? How do we distinguish, right? There's one constant in recognizing the meanings of these principles. If you open your arms like this, right, you have formed, do you guys see me? If you open your arms like this, you have formed that symbol. The opening side is always larger. So it's a larger number. On the other side is always smaller. Does that make sense to you guys?
Mm-hmm.
Does that make sense to you guys? Yes? It doesn't matter which direction it opens, because you can use them flexibly. But one thing is certain, the opening side, right? The opening, which is a larger size, is always larger than the other side, which is smaller. That's the constant in these expressions. So that's number one. Hope to help you to recognize the symbols and understand its meanings. And the next one, when we write something like this, we have turned into or to and. So what's the meaning of the latter statement? Right? What is the meaning of this guy? The meaning of this one is all number, that is all number, right? It still have that all number that is greater than or equal to 2 or and smaller than or equal to -2. You follow me? All number that is greater than or equal to 2, which describe this piece, okay? And smaller than or equal to -2, which describing this piece. And the way you put it there, the way it's put up there, right? You put them in a connected form like this, automatically have changed the or to and. So the meaning is completely different. If this or refers to the truth table or, and this and will refer to the truth table in and. I want you guys to read the latter sentence over and over again. For that solution, right? It means that, oh, not this one, sorry. Okay, so I'm gonna bring you the picture. I want you guys to write down this statement. Write down this before I show you something else. And I want you to see, I want you to make sense after you write down the words and you think about it. What does that mean? After you write it down, I'm asking you, so give me a number that is greater than or equal to positive 2. So after you write down this sentence, I want you to give me a number that is fitting to that description. Can you give me a number like that? Are you guys writing them down?
Mm-hmm.
Try to make sense out of it. And then you give me a number that is greater than or equal to 2 and smaller than or equal to -2. Can you give me an example of such a number? Right? Can you give me that? You guys know what to do? That's the meaning. And then after you write it down, you want to give me a number, any number that is greater than or equal to 2 and smaller than or equal to -2. Anybody? Have you found a number like that? Any comments?
There is no number greater than or equal to 2 and smaller than or equal to -2.
That's right. Such number does not exist. Right? Thank you. Such number does not exist. So in this case, you can totally find a number that's less than or equal to -2 or greater than equals to 2. You can easily give me that number, right? But in this case, the description, because the meaning, it doesn't exist. It doesn't exist. Such a number does not exist. So that change is significant. But I see this very often. I would say every semester, every course I have taught in the past 20+ years, if I add my TA experience, right, when I was in graduate school at USC, I saw these mistakes more than I expected. Right? So this is a rampant, terrible, horrible, extremely bad mistake. That shows the student have no understanding of meaning, no understanding of inequality, the meanings of the signs. Tragic, tragic. Okay, so this is why I want to go over these to focus on the meaning, right? You need to understand the meaning. If you don't understand the meaning, you just look at the form, say, oh, I'm going to put it on this way. You might feel smart or feel like sleek, you can do this. But you need to understand or and and. This is the fundamental reason. Okay, I introduce truth table in all of the algebra classes I teach, including calculus class if I teach it. I introduce truth table to all of those courses for exactly this reason. You need to understand and or relationship Okay, you need to understand and/or relationship. And of course, the truth table is going to be on your exam. The truth table is going to be on your exam, right? It's essential because that's the truth table, I would say, I'm not exaggerating at all, is the building block of mathematics. It's also the building block of computer science. What I mean the building block, I mean the building block is the bricks and the mortar of computer science. And it's also the building block of mathematics. So when you use these two words, you have to be very, very careful. Okay, you can't just say, oh, this and that. Well, you need to think about it. Should I use and or should I use or? Do you guys follow me?
Mhm.
And it's for this reason, mathematics trained us. Okay, mathematics is a subject that is training our brain. We're training our, I would say the reason mathematics courses is required for most of your majors, I would say for probably 99% of your majors, because it's a basic training. It's not a basic training about numbers. It's a basic training about logic. It's basic training about logic. It's not about number, it's about logic. Okay, I think, in my opinion, the missing of these truth tables and the lack of understanding of truth tables is at the root cause of these mistakes. Okay, correct me if you have other evidence. I've seen this mistake for, as I told you, 20 plus years. 20 plus years. All right. So with that said and done, I'm gonna do two more and then it's your turn. Okay, I'm gonna do two more and then it's your turn. The two more I'm gonna do is number 7 and number 8. Number 7, the absolute value of 3 times a number plus 2, right? Less than 4. Okay, so to set up, right? And we understand which kind is this, right? This is the kind, less than. This is the less than. So in your mind, you'll be think out aloud. Okay, this is the kind of work you put on scratch paper. You don't need to show your professor, but you need to have this model in your mind. And you need to have that picture in your mind. Okay, that picture, what that picture? I'm going back to that picture, to these two pictures. These pictures. You need to have these pictures. In your mind. If you don't have the latter picture, because the latter picture is not taught as often, you should have this picture. But the good news is that most of our students have this picture in your mind. Because I always see like 99.9% of the time in the past 20 plus years, I see students, they will be able to draw this picture correctly. Okay, which is great news to me, However, they will make all kinds of mistakes. And sometimes, of course, they are correct work and they make all kinds of mistakes when they're setting up the inequality. Okay, so I'm gonna give you the right, the simplest way to do it. The simplest way to do it is to understand that picture, understand that piece, okay? And your, in this situation, right? They are the same model. Omega is 3x plus 2. And 4, and this turning into 4. So this is omega between -4 and +4. So this will be the first step you set up your inequality. Guess what? Your professor love to see the next step. If you can make it that way, if you understand what you're doing. When you solve this inequality, if, then. That's all you need to do, really. Any other way to do it is either redundant or maybe confusing. All right, let me assure you, the professors teaching mathematics subject all over the world, they would love to see that the next step, just like that. It means and. It means this graph. It means that. Whichever one that works for you. Okay, so in your thinking out loud, these scratch paper work, you don't need to show the professor. All he or she ever wanted is just to see the next step, like that. Okay, I'm not going to promote any other things at this point. If I see them, I will, I will tell you, I will comment on it. I'm not going to give you other forms. So like, this is the best next step. I mean, this is the best next step. Did you hear me? Did you hear me? However, you have learned other ways, I don't know, because you guys coming from different teachers before, you might be taught in different ways, no problem. There are other forms, but I don't want to promote them. This is the one I promote them because this is considered the best step after this guy. And how do we read it? If this is true, then. If, then. So like yesterday we went over, right? How we read mathematics. If, then, if, then, if, then, if, then. Right? And this is the start with the if statement. So the next step, you subtract both sides by 2. Right? So we have a -6 less than 3x less than 2. And then you divide every side by 3. You have -2 less than x less than 2/3. And you're done. You're finished. You finished. You guys see what I'm showing you here? That's all you need to show. If you can show this piece of work like that, I guarantee you always get full credit for it. You can draw pictures. Of course you can draw pictures. If your teacher asks you to draw pictures, go for it, right? How do you draw a picture? Just sketch it, right? Math teachers are the most lenient when it comes to picture. Why do I say that? Because we're not going to measure, we're not going to use a ruler to measure, oh, your tick mark is accurate or not. Okay, we're not going to be like an architect, right? To measure your tick marks if they're consistent. We're not going to do that. All we ever wanted to do to see is that you mark it, right? So I'm going to mark, this is -2. Hold on. Okay, so all you just have to mark, that's why I make a marking the point. Remember when we did all those markings, right? Did we do all those markings when we're doing pictures? So this point is -2, and I'm going to mark another point, 2/3. You just need to make sure these two numbers are marked at the relative correct position. In other words, the negative number should be shown on the number line as smaller than 2/3. Do you guys follow me? We just need to relatively correct, relatively positioned properly. Whether the tick mark is reflecting that, whether the tick mark is measured properly, precisely, it doesn't matter to us. Okay, it doesn't matter to most of you math professors. I trust me. I have met many of them. And you just have to mark your answer, which is right here. That's all. That's all you need to mark. Then you say, oh, are they gonna, I'm gonna put the 0 somewhere. I'm gonna put a 1, 2, 3. No, you can save all of that. That's all you need to show your math professor. And I guarantee you can get all the credit you need. Do you understand? You don't need to spend time to put 0, -1, -2, and so on and so forth. No need for that, for all of that. You're done. You're done. Are you guys with me? But you must understand all of these things I put in think out loud. Those need to be in your head. Those need to be in your head. And you also need to understand the other comments I put here. Okay, that powerful statement I put in here. The absolute value of anything is at least 0. A lot of the questions that your professors are testing you about is about this statement. Like we went over yesterday. We're just testing you if you understand this statement. That's all. That's the focus. You follow me? In terms of showing work, that's it. Nice and clean. Nice and clean. All right. Did you write it down? So shall we move on to number 8? So I'm going to do one of each type, and then you are going to, then we're going to do the breakout rooms or whatever, and this is your practice time, okay? Now, I'm going to clean this up. Let's look at number 8. Number 8 is larger than 5x minus 2. Oh, wait, sorry. I meant to pick up a greater than. Sorry, I'm going to pick up number 10 instead. Sorry. I want to pick up a less than, I want to pick up a greater than, right? So 8x plus 3. Yesterday, I was working this with my other class. It seemed that these questions bothers people because they don't come up as integers, right? Sometimes these come up as fractions. I sense this intense fear about fractions from all of my students, most of my students in the past, and maybe today. Why such a fear for fractions? Why such fear for fractions? Tell me, why such fear for fractions? Why such fear for fractions? Can anybody tell me why such fear for fractions? Yeah? Anybody has any comment why we have such fear for fractions? Because this is something I'm very much bewildered as a teacher. I know such a fear exists. I know such fear exists. Okay, so once again, we have a think out aloud. Right? It's this model that's fitting in our case. Right? You understand the picture, you understand the graph. Most people understand this picture, which is sufficient, This latter one, I would say, is more like, it's added because we're getting into the function and you're going to be using function in calculus, right? What puzzles me, right, is why we have such a fear for fraction. Okay, so before we talk about the fraction thing, okay, you guys think about it, right? If you would like to have give me some comments about why such fear for fraction, right? You can put in the comments on chat. Okay, I'm going to come back to it. So this question is fitting for this omega. What is omega? Omega is 8x plus 3. That's omega. Do you guys see that? That means anything. Anything including being 8x plus 3. Do you follow me? So omega will be like that. And of course, we have 12 here. Instead of 3, we have 12. Do you see that analogy? Do you see that analogy? So these two questions are the same in nature. They're the same in nature. Only the graph will be different. So these graph will be just for omega. Okay, but this gave us a setup. The setup will allow us to get out of the absolute value sign, right? So we will have 8x plus 3 less than negative 12 or 8x plus 3 greater than 12. Okay. If I'm to grade students' work, to me, this step is very critical. I give 1 point to this part, 1 point there, and 1 point there. Okay, so that's my grading policy. Okay, that's my grading policy. So that's 3 points. And every words count. Every words count, right? I didn't mention the grading policy earlier. I would also give 3 points over here. So this is 3 points as well. Okay, if I am to grade work, okay? Same thing, same policy, and or. The or case, there's no combination, there's no combo, no combo. You have to separate because we talked about that earlier, right? And is only for that special case. You can call it true train case, right? True train case, true train case. If that will help you remember. True train case is only for the AND case. It's only for AND. Okay, but once you put up there, you have to make sense out of it. You have to make sense out of it. Okay, so once we set up this step, you're gonna solve these two inequalities separately. And in your mind, you must have these pictures. You have these pictures, you must. Okay, but in terms of what you want, whoever's gonna give you points wants to see. Okay, this is what we want to see. Okay, we want to see the following steps. Less than negative 15 by subtracting 3 on both sides. And this next one is 8x plus 3. I'm sorry, plus a minus 3 on both sides. So that's going to be greater than 9. And next, X will be less than negative 15/8. Is my arithmetic correct? And the next one is X is larger than 9/8. Okay, I will typically give this step 2 points, right? So this is 2 points. So this will be a typical 5 points questions, but you can see the weight by the weight I put in there, right? You can see how important that first step with 3 points is, right? Which is also, I'm also consistent in this case as well. If I am to grade your work. From the points distribution, you can see how important it is. Do you guys see that? Right? This is critical. This is basically like setting the tone. Okay, if you're a musician, then that's the main melody in your music. Okay, if you are a painter or you're a kind of artist, right? That's going to be the main meaning in your art. Okay, if you're missing or, okay, if a student missing or, oh boy, if you're missing this or, then as the teacher who assess your work, you're gonna set her up to a new search, because if I were to grade the work, I would say, does the student know whether it should be and or? You know how much emphasis I have on and or, right? Now, those are the building blocks of mathematics, computer science, all the basic science, and or are the building bricks and mortar. Right? So you have this or missing. So I'll be looking through all over the places on your paper to find it, to find a clue as you understand it or you don't understand it. Do you guys understand how much work you set me into? I mean, I'm gladly to do it. It's my part of my job. Right? So if you are really want to make it easy for your professors and also get the most point, you just put the or there. How much extra strokes you need to, how much it costs you to do that, to make it nice and crystal clear and get all the points, right? For some reason I see, but so that's how much work you need to show. If you have to show a graph, suppose some professor asks you to show a graph, I don't, okay? I just want to see these inequalities. I really don't care much about the graph, okay? Because I imagine you know the graph, right? Until I'm proved, otherwise. If you are to show the picture, hold on. Okay, make it thinner. If I am to show the picture, right? So I have two numbers, right? Negative 15/8 and 9/8, right? This is a positive, that's negative. Negative is smaller than positive. So negative 15/8 is going to be on the left, right? Negative 15/8. And the other number is the positive. So I'm going to put the other number 9/8, right? And then this is less than, so I'm going to put two circles. To put two circles, right? And less than means on this piece. Greater than means on that piece. As far as those tick marks and zeros, you can save them all. You don't need to mark them. And I guarantee you're not going to lose points for it. Okay, you're not gonna lose point for it. Anywhere you go, trust me. If you go to Berkeley, it should be fine. If you go to Harvard, no problem. Trust me. If there is a problem, come back. I give you $100. Okay, $100 cash. You bring your work, right? You tell me your Harvard professor said you didn't mark 0, -1, +1 in this situation, in similar situation, and you lost 1 point, you lost 2 points. I will give you $100. All right. Okay. With that said and done, and that question is complete. That question is complete. You should get all the credit you deserve. Okay, if this question is, if this problem is 5 points plus the graph may be giving you 3 points, 8 points. You should get all 8 points. You don't need to show think out aloud part, but you need to have it in your head, in your mind. Now, we're going to talk about common mistakes. Common mistakes. Okay. Before I talk about common mistakes, I want to emphasize one more time how your work is read. How your work is read. Okay, how your math nerdy professors read your work. Okay, I believe we read your work all the same way, whether you are a professor at USC or you're a professor at Harvard, or you're a professor at Stanford, you're a professor at Berkeley, doesn't matter. They read your work the same way. If then, if then, if then. That's how we read your work. And we just check from if to the next then, is that logical? Is that correct? So we're judging from one step to the next. One step to the next. All right. So with that said and done, let me point out some of the common mistakes. This common mistake I have to point out because it's so common. And it's so common. I see it every year. Okay, this is a common mistake I'm about to show you. Okay, to start with, the student will write -12 larger than 8x plus 3 larger than 12. Okay, and then the student will write -15 larger than 8x larger than 9. Okay. And the next step the student's going to write is -15 over 8. You may wonder why I remember these so much, because I see them every semester. Every semester I see them. This semester I'm kind of spared because of my medical leave. Right, I won't get to grade your work like that because if I were to teach this, continue up to the end of the semester, I will give you written quizzes to show your work. I certainly hope that I won't see such mistake, but I have definitely saw them every semester in the past. That's why I'm saying this semester I may be spared of this trauma. Right? So this is students' work. And then the student says, okay, the solution is this, is x less than, oh, they will put the entire solution over here. Okay. And the student will say, hey, I got the right answer. I got the right answer. And this student, the same student, most likely, he or she is going to show the right picture. Okay, that picture. Okay. So in this case, how many points should this student get? How do we grade the work? How do we grade the work? right? The student draw the picture and have the picture in place. And the picture is correct. Okay. This, I already explained to you how your work is being read, right? How your work is being read. So why we give points according to steps. Each step has to be correct to lead to the right answer. So now, with that said and done, with that being mentioned, when we check your work, we check from this step to the next step. If, then. If, then. Right? If, then. So if this is true, then. And right here, it's wrong. Do you guys see that? Do you guys see that? Because you're telling the reader, if the absolute value of 8x plus 3 is larger than 12, right? Think of 8x plus 3 as a 12, as omega. Okay, think of this as omega. You're telling me that omega is going to be greater than 12 and less than negative 12. We know such a number does not exist, right? We know such a number does not exist. So because this step is wrong, you automatically lose 3 points already. Okay, you automatically lose 3 points already. And the remaining steps, right? These 2 steps is a consequence of this critical wrong step. So you're not getting the other 2 points. Now, you claim the solution is such, right? So in our mathematical language, you're telling the reader from here, right? If, then, this is what you're telling us. This implies and does not imply or. Therefore, you're going to lose another 2 points. You might get a picture, you might get some points, because when I encounter this case, this is one of those very difficult cases to grade, because especially when this is not just one student, there are multiple students. I have to make sure the grading is consistent with everyone, right? I might typically give 1 point or 2 for the correct graph if I'm asking for graph. But you have lost most of the points. Okay, and I don't know where our student learned this. I just, that puzzles me, because if there's only a handful of students doing this, is that I see it every semester. So I wonder, maybe someone is teaching this way somewhere down the, in the past. That's something I don't understand. Okay, so if you guys have any clue, I wish you give me some hint. Okay, because in my career of teaching, I want to identify the mistakes, and I want to eradicate those mistakes. And I was also told, when I was talking to professors who teaches 4-year schools, and they have similar mistakes. They saw similar mistakes. It's extremely puzzling, extremely puzzling. Okay. So I suspect it might be some, one of my peers or some of my peers is teaching this way, which I would think that's a criminal act. Forgive my language. Okay. However, that teacher, whoever taught you this way, he or she is no longer responsible for your grade. You need to understand that. You guys understand that, right? They are no longer responsible for your grade. You are. So stop blaming them. That is my point. Whoever taught you whatever is wrong, you are going to bear the responsibility. So you need to be actively make sure you understand what you're doing, because teacher could make mistakes. Like I make mistakes. You saw my mistake, didn't you? But doesn't mean you should make the same mistake. Right? So number one, you want to have the ability to recognize that mistake. Number two, you are solely responsible for your grade, for your own success. That's something I think we all need to understand. Okay, so here I'm just giving you the tool to understand. To tell you the truth, I used to have a substitute who substituted me. Well, I was in hospital a couple of years ago for diarrhea. That substitute teacher taught my class the wrong way. I mean, completely mistake. I probably will cover that topics in next before I leave. I have to correct it all over. So I'm not saying every teacher will have to do it correctly, perfectly, right? But guess who's responsible in the end? You. Humans do make human mistakes. Okay, so that's my point. I hope I have said enough about it. So this is one of those mistakes I saw in similar nature over and over again. So let's move forward. Okay, we have passed the middle, the half time, right? But anyway, the next mistake I saw, I would say it's not a terrible mistake, but it is a mistake. Is people will have similar steps, right? But this is what the student written down. The student will write down like this. Okay, so another undesirable work. Okay, the student will write, okay, from the beginning, the student will say, okay, this guy and that and that. And then he said, or I call this broken English. I call this broken English because we read, when your English teacher reads your essay, how does he read it? Left to right, top to bottom, right? Yes?
Mhm.
So when I read this work, how do I read it? I read it from left to right, top to bottom. This logically lead to this, so logically complete. And the next step is also logically complete from the previous sentence. If then, if then, if then. Every sentence, if then, if then, if then, they have to be logically complete. So when you write it this way, which I also see, it's like the student saying, well, this is going to be leading to this. So when we grade it, when we grade your work, right? When we see this, this is how we read it. If then, if then. If then, if then. You guys understand what I mean here? This is how your work is read. In the future, when you start writing program, you understand what I meant. This is a broken English. This is broken English. You guys know, understand what's broken English, right? And what is more logically incomplete, because when I read this piece, right? When I read this piece, well, you said, if this is true, right? Then that. Then I would argue that's incomplete logically, because it could be the other case. You guys follow me? But you put the other case later. How is your reader supposed to make that connection if you don't make it clear? Do you guys understand what I'm saying? So don't do this, because you're leaving loopholes here. You're leaving loopholes here. The best way to present your work is right here. This is the best way. I've been with many math professors, math teachers, and I'm being one myself after being trained by them. In my knowledge, this is the best way. So if you want to get point, suppose you want to get all the points you can get, then you do the best way. How about that? Would that make a deal? You can clearly see the logical flaws, right? You can clearly see the logical flaws. Because if this is true, that omega could be on the left, it could also be on the right. How can you be certain it's going to be on the left? And then you mention the right later. That's like a broken English, isn't it? You say something, you say half of it, and then you say something else, and then you come back to it. What kind of essay is that? I hope I made myself clear. And I think I have left no time for you guys to do work in class today. And I'm going to go straight to review. I'm only going to take 3 minutes break, and we're going to come back at 9:20 because I want to make sure we have enough time to review the materials for you. All right, so let's take 2 minutes break. We only have 2 minutes left. 2 minutes break, and we'll come back. Okay, so I wish to give you guys some help if needed to review for your midterm. Mathematical principles will be on the exam. Truly understanding them is the goal. Okay, truly understand them will be the goal. Okay, so mathematical principles. I'm not asking for memorization. I'm asking for understanding. Okay, so my questions is designed in such a way that they are, well, to the best of my ability. Right, those questions will be about whether you do understand it. Okay, truth table. Truth tables. I taught truth table, and I have talked to you about the importance of truth table. It will be on the exam. Basics 1. That basic 1 table, we have covered all of the functions. We've covered all of the functions. Okay. You may say for archical tangent, I didn't cover that much in this class, but I covered in the other class. So I have left the recordings. I put the recordings in last week. last week with that title. So you're expected to watch and understand. Okay, but if you understand all of arc sine, arc cosine, arc tangent, you should easily understand arc cotangent. Okay, so basic one table is a big thing, right? We spend half semester to doing that. I would say we spent 6 weeks doing them. That shows the importance. That shows the importance. Every single function in that table, in my opinion, in my experience, are of tremendous importance. Okay, so basic understandings, basically, right? Domain, range, intercepts. Right, and the rule, right? So for each rule, right, each rule of function, and of course we have increasing function, one-to-one function concept, right? Increasing, decreasing. Increasing, decreasing, right? Even, odd. These are really all the concepts you need to be aware of. Okay, are there lots of algebraic details in there? Well, they're in the homework. So these concepts are being tested directly, indirectly, right? Domain, range, intercepts, and all the properties about each function, right? If you go back to watch the lectures, every function we covered in great details with consistency, and also to understand the rules. And you can also see that trigonometry played a big role, a big part in it, right? So if you look at the basic functions, one by one, we use a consistent theme to address each one of those functions, and we plot it point by point. And the devils are in the details. So in order to assess you guys' understanding, I have to put a lot of details. And those details are not going beyond what we've done in class and what is being assigned to you in homework. So if you ask me to review about that, I think that's all. Right, and next is your question. Is there anything you want me to address? Right, because I have assigned you homeworks as we cover basic one throughout the weeks, throughout the past, I would say almost 8 weeks. So your turn, your question. My emphasis on the graphing, on the points, on that part, because I've talked to my colleagues from four-year schools, colleges. We all agree that's the part our students need. Okay, that part is called analytical geometry. That part is called analytical geometry. Okay, you think about plotting points, marking points, those things. If that has become easy and trivial for you, that's great. But that's not the case for most of our students. That's necessary, especially once you get into calculus 2. Right, you start to do rotations and to produce from 2-dimensional pictures to produce the 3-dimensional objects. Right, by rotating, revolving, and all of those actions. If you don't understand the basic pictures, there's no way you can do well in those sections. Right, so I hope that these basic things we have done, will lay a good foundation for you for your future courses. But remember, your success in this course, it of course is important, but it's even more important is your success in calculus classes. And those fabulous grade you get from calculus classes will take you to your dream schools, right? You agree with that? Yes? So without further ado, I'll bring you questions. If you have questions on any one of the past quizzes, bring them on. Okay? You need to understand that the solutions to all the past quizzes will stop being available to you midnight tonight.
The one question I have is for arc cotangent and cotangent of x. I'm hoping to know if like the other ways you can write it is available as well.
I don't hear you very clearly. You said arc cotangent and cotangent.
Yeah.
What about it?
When I'm looking at the domain and range, right, I want to make sure like I have like all the possible solutions for the domain and for the range. Like, you know, like the absolute value of arc cotangent is equal to, you know, the other thing.
Arc cotangent. What about it? Can you type your answer, because your voice seemed to be a bit muffled for me.
Okay.
Arc cotangent. I advise you guys to watch the lecture. Okay, so let me show you where is the lecture. I'm going to bring up the topics. Okay, just 1 second. Because I just suspect that I also give time for other questions from other sections. Okay, remember you have all 22 functions to work with. We have covered that in the past 7-8 weeks. Arc cotangent. Okay, so I'm going to bring up that section where I covered from the other class. I think it's here. Arc cotangent. Okay, so this is the arc cotangent. Can you write the range like, yeah, that's correct, Jacob. Between 0 and pi, exclusive. This is arc cotangent. This is a cotangent. So you can determine the domain by noting the sign, you know, because cotangent equal cosine over sine. So the denominator cannot be 0. So what will make the denominator equal to 0? Well, when the angle equals to k pi, right? So that's a domain recognition. And then we select a piece to create arc cotangent, and this piece we selected from 0 to pi. You are given homework as to do the points between 0 to pi, and also recognize the endpoints, right? What happens when the input approaches 0, or the input approaches pi? Approaching 0 from larger than 0, approaching pi from smaller than pi, right? In this case, you can see it goes up to infinity, right? Positive infinity, and this one goes up to negative infinity. So they're all in the lectures you would like to watch. I would say you guys should watch. Okay. So understanding that it's very similar to tangent. It's very similar to tangent. So if you don't have a whole lot of time, you don't have to study that in details, because I will not be testing you about cotangent, tangent extensively, okay? Because the main questions, the main functions here are about trig functions, sine, cosine, tangent, arcsine, arcotangent, arccosine, arctangent, arctangent. Arcotangent are used, but they're very similar to tangent. So as long as you watch that video, watch the recording, you know, once, maybe twice, it depends on your time availability. I know everybody, you know, have their you know, life to live. It's very similar. So that video will summarize it. In the inequality part, right? It's between 0 to pi, between 0 to pi. So you can also write it as 0 over here, right? 0 less than arc cotangent x, which is less than pi.
I have another quick question.
Yeah.
In the notes, so when you were doing like all the graphs and for the domain range, you mentioned for arc cosine, the absolute value of arc cosine of x minus pi over 2 is greater than or equal to pi over 2 for cosine. No, for arc cosine, my bad.
What did I write?
For the section of arc cosine on the range, you said you typed out the absolute value of arc cosine of x minus pi over 2.
Okay. Arc cosine
Of x minus pi over 2.
Okay, I know what you're saying.
Okay. Do we have like for that? Do we have to know that kind of?
No,
Okay.
no. This is the, you know, but since you asked this question, right? Since you asked this question, because we know that arc cosine is between 0 to pi. It doesn't really have a straightforward absolute value expression. But we can actually create one. We can actually create one, okay? Because from this inequality, okay, you can subtract pi over 2 on every side. It's not beyond your ability to do it. That's what I'm saying. It's not beyond your ability to do it. Okay? Okay? So when you subtract subtract pi over 2 on every side, so you're gonna have this behind between arcsine x minus pi over 2, that's between negative pi over 2 to pi over 2. So in that sense, you will get an absolute value form. You get an absolute value form. So depending on how familiar with your absolute value, okay, especially we just covered absolute value, just review that part. So this is how you can manipulate it into that form. But you should definitely know this form.
I see.
Okay? This piece is optional, but it's not beyond you. Okay? It's not above you. And it's not beneath you either. Most of our students, I would say most of our students, because as I said, I've taught more than 20 plus years, is algebraically underprepared. It's like manipulation like this is expected of your professors. But in reality, we know that's already very hard for most of you. And this is also the part of the reason I give you lots of exercises. Okay, I went through many books, many textbooks, okay? And I selected these questions, I put them in the notes. You can see that in this course, before you enter calculus, you only have these concepts. You have some mathematical principles, truth tables to understand, these one-to-one function, increasing, decreasing, even, odd function, just these concepts you need to understand. And of course, function is being a big thing, a big definition, right? Which I think is not addressed enough. So I want to address that. I've been addressing that throughout the course I've been teaching. But for you, when you face this notes, if I were you, I would just do one question after another, just to enhance your algebraic skill. But that's something I cannot do for you. That's something I cannot do for you. You understand, right? I cannot do it for you. I wish, I wish I can pass down my knowledge in mathematics to my children by blood. And you understand that's not possible, right? I cannot do it for my children either. I have 2 children, right? So that's something you have to do yourself. It's just like you work out, you work out, nobody can work out for you, right? So those are things you must do it yourself. So in terms of the recording, okay, in terms of the recording, the lectures, and I think one of the benefit of having these online teaching, not in person, does come with its benefit. So when you look at this, right, when you look at the module, you can go by the weeks, right? Each week, week 1, 2, 3, 4, 5, this is the first week, right? I try to put those titles. For example, this language of mathematics, principles, right? Mathematical principles, basic functions. You can see we started to cover basic functions in the first week. So we actually covered 7 weeks, right? 7 weeks. And these are titled summary of the 8 basic functions, right? So from the table, the first 8 we covered. And then we did increasing, decreasing function. And then we covered exponential log function. And very soon, these exponential log functions was covered in 2 weeks, I believe. 2 weeks. Because we also covered the inverse functions. So a lot of these titles there, right? All the topics here, these lectures, they're not dated. They're from my past lectures. But the coverage and the way the styles are similar to what I do in this course. There are differences, right? And week 4, you see, we do log for more than 2 weeks. Exponential log more than 2 weeks. And of course, they're going to be on the exam. And trigonometry. Trigonometry, we did it for 3 or 4 weeks. We did it for 4 weeks. So that was the heaviest, right? So you can go through these topics, right? I said the devils are in the details. Indeed. I can tell you we're going to cover the basic stuff. What are the basic stuff? The basic stuff are all covered in the lecture, in the lectures. So what I hope is that you should watch the lectures over and over again with your paper pencil next to you. Maybe replay certain part over and over, because if you do that, if you have been doing that, then you're in good shape. But if you say, I only watch it once, most likely you're gonna miss a lot of things. Do you understand? Because I imagine I'm just one of you. How would I cope with this? This is 5 classes in one. This is 5 classes in one. 1, 2, 3, 4, 5. By this time, I think you agree with me, don't you?
Mhm.
Right? So these topics. So the material covered, right? With the dates. Those should be served as some kind of guideline. Regarding arc cotangent, let's see, arc cotangent here, you know, arc cotangent is covered. So I put that video there. Okay, I think I'm up to date with that. And here, this date is the other topics that are not, they're not dated. Those are the old lectures. Those are the old lectures from my last semester, Okay. Your midterm exam is almost ready. I would just take the last look just to make sure I don't make any stupid mistakes. And they will be available in the morning tomorrow. Okay, you have 3 attempts. Each sitting is 60 minutes. How many questions? I think about 35 questions. About 35 questions. You have more than 1 minute for each question. Okay, you can do it again and again. Between each time, before you take it the first time, okay, before you take it the first time, you want to prepare thoroughly, okay, according to these topics, right? The rule, the definition, the points, all the devilish details, Because if you don't touch it, your professor will touch it. Okay, homework, right? A lot of the questions I put on the exam are inspired by homework. I have given you homeworks, right? The homework is updated every week and sometimes daily. Let's look at the homework piece. I don't know how many, if you guys do homework. Right, their homework on cotangent, tangent, right? These are the new homework in addition to the homework I have assigned you in the notes, right? And you can see the homework is reflected the lecture. The homework reflected the lecture. So these are the homeworks that have been assigned to you since the beginning of semester, right? So my exam is very much consistent with homework, with lectures. And you probably already know a lot of the quizzes questions I give you are from the lectures, right? Are from the lectures. And the midterm exam is no exception. What I hope, okay, under our pandemic circumstances, if anything, you will watch the lecture over and over and follow the steps and work it out when you're watching it. And that will be most beneficial for you. Because I don't do online homework. Right? You need to commit yourself to write it down, to show work and stuff. Okay, I don't want to talk too much. How can you guys bring your questions? I'm here to help.
Another question I have is, do you think we can quickly go over the points for cotangent and cotangent, or is that not possible?
Sure. What are the points you want to go over?
Can we go points over pi over 2, 0, 2 pi 3, and then negative pi like 3 over 3? And
You mean the table? I assigned as homework?
no, like back in the points a little bit on that one, like back in the points.
Back to what point?
Can we try graphing 2 pi over 3, 3 pi over 4, and 5 pi over 6?
For cotangent?
Yeah, for cotangent. And for arc cotangent, can we try plotting the points for negative radical 3 over 3, negative 1, and then root negative root 3?
So provided you guys understand the domain and range for, right? Because the selected points is very much related to the domain and range, right? So that's a cotangent curve. Yeah. So I'm asking you, Jacob, is the points you refer to, do you refer to the points that's from the homework, or you have, I believe those are from homework, where you mentioned some 2 pi over 3 and stuff. Can you
Yeah.
can you kind of type it or send me a picture? I cannot follow you.
Yeah, it's within the homework you gave us. It's on 10-14 on the homework, and you said to complete the table and mark the points on the graph.
Okay. This one, right?
Yes.
So you want to work out these points?
No, I already worked out the points a little bit. I just need to know like where they go on the graph, kind of.
Okay. You know this is pi over 4, right? When input for cotangent is pi over 4, the output is 1. How do we get the 1? You take the red divided by the blue, right? That's a cosine divided by sine. So that point goes there, right?
Mm-hmm.
Pi over 3, pi over 6, root 3, pi over 6. You're gonna approximate it, okay? I know none of these points can be precise, right? You're gonna approximate it. So pi over 6 is smaller than pi over 4. So that point is going to go, if you measure pi over 6 is, you can get an approximation, right? Pi over 6, you punch in the calculator, you get approximately what? You get more than half, right? So that orange would be something like this, right? More than half. So it's going to be something like that, right? That's half, more than half. And root 3, which is you do the pi over 6, we're going to take the red number, divide by the blue number, you get root 3. And that number, I'm going to use the color this light purple, something like that. So that point is right here. So that point is going to be what?
Pi over 6 and then root 3.
Pi over 6. Right? And then you do the rest of pi over 3. Pi over 3 is more than pi over 4. So it's going to be somewhere here. Somewhere, right? And then you do pi over 2. And so on and so forth. So you mark them in similar manner. Do you know what to do now? Or you want me to mark them one by one for you?
No, can you just do 2 pi over 3 and 5 pi over 6, and that would be it for cotangent.
Okay. So the next points you want to mark. Two pi over 3, right? This one over here?
Yes.
So cotangent 2 pi over 3. Right? So you're going to measure your angle. This is ARD. This is ARD. So you measure 2 pi over 3. Just this picture doesn't. Okay. Cotangent 2 pi over 3. So you're going to do the ARD. You measure from the standard position. You get to here. That's 2 pi over 3. This angle is 2 pi over 3. That arc length, right? And you end up at this, you pick up a point on the terminal. That's the red is a -1/2. The blue is √3/2. The red is a cosine. The blue is sine. So red divided by blue, you're getting negative √3/3. Yeah. So the point is going to be input 2 pi over 3. And the output is a negative √3/3. And on the picture, 2 pi over 3 is more than pi over 2. So you're going to measure your orange. Okay, you measure your orange somewhere here. 2 pi over 3 it's probably a little over 2, something like that. You can get an approximated number, 2 times 3.14 divided by 3. Okay, that's the orange. And the ratio, which is negative √3/3. And that purple is going to be something like that. So that's the point. And this point can be marked as the orange, 2 pi over 3. And the output is √3/3. Oh, wrong color. Negative √3/3. Does that make sense to you?
Mm-hmm.
And what else point you want to do?
Can we go to arc cotangent and do point negative radical 3/3?
Arc cotangent. Arc cotangent negative root 3 over 3. That actually equals to 2 pi over 3, right?
Mm-hmm.
2 pi over 3. So this point, the input is ratio. The input is ratio. The output is 2 pi over 3. And this point, in that picture, negative root 3 over 3. Okay, negative root 3 over 3. So it's going to be on the negative side. This is the arc cotangent curve. Okay, so the ratio is going to be negative root 3 over 3. That number, I would say, is rather small, but it's negative, something like that. Okay, and the output is an angle. The angle should be 2 pi over 3, so it's somewhere here. So that point, this point will be marked as the ratio of a negative root 3 over 3. The output is an angle. The angle is 2 pi over 3. Get it?
I see.
Any other points?
No, but I have another question. If we have enough, do we have enough time for one more question, or is that what?
Well, if nobody else is asked questions, you can just keep asking. And anybody else want to ask a question? Anybody else has a question to ask? Okay,
Can I say my question then?
well, go ahead.
So my last question is, would it be okay if you were able to do like a small little recap on increasing and decreasing functions, like a small recap on it, or would that be too much?
No, it's not too much. This is decreasing, this is decreasing. Right, tangent are increasing in that
Wait.
interval.
Wait,
Right?
cotangent is cotangent is decreasing?
This is a cotangent curve between 0 to pi, right? This is decreasing. Yeah. What's the definition of decreasing?
Give me 1 quick second. Decreasing function, a function f is called increasing on interval I if f of 1 is greater than f of x2 whenever x1.
Whenever, right? Whenever input, whenever x sub 1 is less than x sub 2, the output f of x sub 1 is larger than f of sub 2. That's decreasing. Right? So whenever this is true, so for example, look at the arc cotangent. Right, we just talk about arc cotangent. This is arc cotangent, right? This is arc cotangent. You arbitrarily chosen 2 points, right? I arbitrarily chosen 1 point, x1 here, x1 is less than x2. Right?
Mhm.
X1 is less than x2 because x1 is on the left, x2 is on the right. The number on the right is larger than the number on the left, right? And what are their outputs? The output for x1 is this. The output for x2 is that. This is f of x1. And this piece is f of x2. Okay? And the points, this is a point, this is a point. This point here, x1, comma, f of x1. And this point here, the input is x2, f of x2. Whenever x1 less than x2, f of x1 is larger than f of x2. Whenever. The key words here is whenever. And this is the case which is decreasing. Does that make sense? And then we can look at increasing. So you can choose arbitrary x1 less than x2. You can pick your x1 here, right? x2 here, x1 here, x2 there. Arbitrarily chosen. Whenever means x1, x2 are chosen arbitrarily. But x1 is smaller, one is less than the other. And the output will be, the relationship of the output will be reversed. That's decreasing. So that's the visual. Do you guys see that? X1 is less than x2, but f of x1 is higher than f of x2, larger than f of x2. Yeah?
Uh-huh.
That's a decreasing.
Okay. Can we do an increasing one, or are we out of time?
We got time to do increasing, sure. Well, time is up. You guys have to go. You can go. So increasing.
Professor, is that Thursday longer period?
Yeah, class ends now. But I'll go over whatever you have questions. Okay, not a problem. So let's look at increasing. Okay, so that's decreasing. Hold on, let's see what file do I have here? Okay, that's the other file. Okay, so increasing, decreasing, right? So that's decreasing. Let's look at increasing. Okay, so we can use arctangent if you want, right? Arctan, the curve of arctangent. Right, this is arctangent. We know arctangent has a domain all real numbers, right? All real numbers. What's the definition of arctangent of increasing? Whenever f of x1, whenever the input one is smaller than the other, f of x1 is going to be smaller than f of x2. Right? So you're going to pick points arbitrarily. I'm going to pick a point here arbitrarily, and I'm going to pick a point there, right? So this is x1. That's x2, right? x1 is less than x2, whenever, right? Let's see what is f of x1. F of x1, this is f of x1, and this is f of x2. Which one is larger? They're both negative, so the shorter one is larger, right? Right, so this is f of x1. And that's f of x2. F of x2 is greater than f of x1. Whenever this happens, this always happens. And you can choose these 2 points arbitrarily. I mean arbitrarily. So you can choose x1 here, x2 there. That's going to be true, right? Because the output is going to be, these are the outputs. This is negative, and that's positive. Positive is larger than negative. You can choose points here. You can pick x1 here, x2 there. Same thing, it's always true. That's what we mean arbitrary. Arbitrary means it's going to be true all the time, whenever. If this is x1, x2, x1 is less than x2, then f of x1 is less than f of x2. Does that make sense?
I see it.
And similar increasing function like e to the power x, ln x, 2 to the power x, log base 2x, and we have seen those, right? At the time we addressed those issues. They are all increasing functions. If you take a second look of that basic one table, there are wealth of information out there. We have addressed them all, right? Increasing, one-to-one, increasing, decreasing, even, odd. So for every single one of those functions in that table, you should be thinking about these concepts. Whether they are or they are not, right? Any other questions? Yeah. No problem. Go ask. No question. No problem.
No, I was just going to say, let's say for an example, give me 1 second, I can find one. Okay, let's say for example, log base 2 of x. Would we have to like find out if that's an even or odd function, or is that only?
Do you know how to find out if they're even or odd?
So yeah, an example would be like if log base 2 of x, right? Let's say example for that. Would we have to find out if that's even or odd?
You certainly should think of it.
Okay.
You should be thinking about applying these rules, applying these definitions to every single one of those functions. That's the student's work, right?
Mm-hmm.
Whether I test you or not, that's a different matter. That's your teacher's, assessment.
I see.
Right?
Okay.
So as a learner, you are supposed to, okay? I know you may not like to hear this. You have to think, because the purpose of education is to broaden our thoughts and observation. You cannot wait for your teacher to say, oh, you need to think of that, you need to think of that, you need to think of that. No. You need to think of that. You need to initiate. So I'm speaking of this in general as from my own experience, because if you don't think about that, someone else will, especially your professors, and that question was going to be on the test. Right? That's reality. That's reality. Bring your question. Bring your question. Any other questions? First?
Yes, Professor. I had a question regarding that 3 attempts you mentioned. How does it work if I'm a student? For example, first attempt, I take it tomorrow morning, and then I'm not happy with the result. I go read my notes, review, my notes, everything. Then I try to retake the test at noon or afternoon. Is that second attempt considered second attempt?
Yeah.
Okay.
You only
And
have
if-
3 attempts. You only have 3 attempts.
3 attempts. And if I'm not happy, I go study more. And in the evening, I try my third attempts more prepared. Is that true?
Yes, that's the intention.
All right.
The highest score will be your score.
Wonderful. So that gives us a chance to, for the last time, to go back, review our notes, review our quizzes, review our homework questions, video lecture, back and forth. So basically the test is wide and not just 1 hour, but 24 hours or something like that because of 3 attempts. You are
It's 3
giving us.
days. It's 3 days.
Oh my God, 3 days. Oh my
Friday,
God.
Saturday, Sunday.
Even better, even better.
Yeah, 3 attempts, 3 days. You decide how you're going to use that 3 days.
That's right.
But the bottom line, you understand everything that's addressed in the test.
Yeah, I can take the first test to get familiar with type of question.
Right.
No, I'm sure you are gonna choose the question from all over the place since the beginning of semester. Therefore, I have 2 days to go back and prepare myself to get a better score for the second or third attempt. That would be wonderful.
Exactly. But I'm asking you, I'm pleading you guys to shoot for understanding, to work for understanding, not for just grades. Okay? You probably will see to pass my exam is not that difficult. Right? Up to now. But you need to commit yourself to understand the material. That's understanding of the material will truly help you for your future success. If you just merely want to just get by, I know there are ways to get by. Okay, no test can be designed so in such a way that it can prevent every possible, undesirable acts. You have to actively commit yourself, say, okay, I really do want to understand this material because I want to be successful in my calculus classes. And you understand that it's how essential it is to understand these materials in order to be successful in calculus classes. Right? The most time wasting effort will be that you get by this course and then you have to take calculus 3 times. To me, that's the worst thing you want. You don't want that. Because if you fail to have calculus class the first time, that's already telling you need to go back to algebra classes. If you fail your calculus class the second time, and that also tells you should go back to your algebra classes, take that 5 class, review the 5 courses. Really, that's from my experience. Student who cannot make a calculus class, most likely 99.9% of the chance is that they are very weak in algebra. But who can make you stronger in algebra? No one else but you. You just exercise, you just practice, practice, practice.
And your video lectures.
I make it very inexpensive for you. You don't have to buy 10 textbooks, just this one, free. But you have to put in the effort. Your time is your money. Right? I used to tell my student to walk randomly into a calculus classroom. You just stand in the back of the classroom and watch. Watch what the professor put on the board. The board is covered with algebra. If you're algebraically unprepared, how can you possibly pass it? Impossible. Okay, if you look at the early mathematicians, right, who have invented calculus, like Newton, Leibniz, these mathematicians, they are super strong in algebra. Okay, otherwise they wouldn't be able to derive all those complicated situations. But don't think they do that because they have nothing else to do. Okay, the invention or the discovery of calculus has much to do with the modern technology, the development of modern technology. It leads to the inventions, you know, we have enjoyed tremendously today. Calculus has a lot to do with modern technology. But anyway, I'm gonna take more questions from you. So my exam is designed for people who want to learn. Okay. And want to make the grades and want to make grades continuously. That's my intention. I don't think about other things. I don't think about, oh, how I'm going to prevent cheating. I'm going to prevent this, prevent that. I can't. I know I cannot prevent cheating. Right? That's just the human nature. If you want to go, if you want to head way, if you want to head that way, there will be consequences waiting for you, and that's not my business. I'm not in the business of catching people, right? Are you cheating? I don't want to be a police officer like that. I only want to teach people, and I'm committed to you if you want to learn. If you don't want to learn, there are a million ways to do it.
We have 8 more weeks to change our style of learning from memorization to true learning, as you telling us.
I hope so. I hope so, because I personally could not have survived my academics career had I just memorized. By the way, my memory was very good. I have very good memory. Okay, it's not that I'm not one of those people who forget people's name and don't remember much, you know, have poor memory. I have extremely good memory. I mean, I sound like boasting, but I would say my memory is pretty good. But I cannot rely on my memory. I know how frustrating it is. Okay, very soon I get frustrated myself. I cannot rely on memory.
Professor, my last question is, one of the students asked me in Math Study Center, is it the absolute value concept we learned this week is going to be on the test?
Absolutely.
Okay. That sounds good to me, because if we learn it, then we can get our points in that regard.
You want to get those points, right?
Yes, yes.
The basic concept of absolute value. Okay, the basic concept of absolute value, like domain, range, or those sort of things, we have covered them. Absolute value is on the midterm exam. If I were to give you final exam, it will be there too. Because remember, I told you there'll be at least 20 points for you to 20 points waiting for you in your calculus classes. How could I downplay that importance? I will not be teaching you a calculus class. You will have to deal with that. And your other professors have at least 20 points there waiting for you. Okay.
I'm gonna leave and prepare for next class, Professor, if you let me.
No problem. It's my office hour. So if you guys don't have any questions, you can go, but I will be heading to my office hours. And in fact, I'm late. I'll be there waiting for you. Okay, I wish you the best of luck. And I will see you guys on Monday, if not sooner.
Thank you very much, Professor.